Hello! In this video we're going to be doing some review for what would typically come up in your first midterm at IU in M118 or somewhere in your first midterm in most finite classes. So we're going to be looking at the review exercises first from chapter 1 in this video, and they're not so bad. I'm going to do 2 problems in this video, but I think you're going to find that they're pretty straightforward. So let's go ahead and check those out. So chapter 1, what was that? That was sets, partitions, and tree diagrams. So I'm going to look at problem 11 because I think this pretty much exemplifies one of the problems you're going to see on the midterm. They don't want to give you anything that's going to take too long, but they want to give you some stuff that's going to make you think and show that you know what you're talking about. So this is number 11 in the review exercises for chapter 1 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. And the first thing we're going to do, of course, is we are going to read out the problem. So the staff at the Metroburg Zoo asked visitors to complete a survey concerning visits to the primate house and the elephant house. The results were 246 of the visitors went to the primate house, 271 visited the elephant house, and 185 went to both. How many of those people visited only one of the two? Well, this might seem a little intimidating, but it's really not so bad. So it's midterm. We want to write down what we know, but we also want to write down in an intelligent way. So I think this sounds like a Venn diagram. I don't know about you. So we're going to do this as a Venn diagram. So I've got, let's say this is the, let's see, which one do I want this to be? This is going to be the elephant house. We're just going to put a big E there. I would try to draw an elephant, but I would fail, and that would just be sad. And let's see, 271 visited that. Okay. And let's see, this is the primate house, not to scale. 246 visited that. And then what else do we know? Well, we know this bit in the middle here. Well, we know that those are the people that visited both, and that is 185. Okay, I'm going to label this. This is problem 11. Again, this seems bad, but it's not so bad. So what do we need to know? Well, we need to know who only visited, and I'm going to highlight this in green. We need to know who visited this and who visited this. So people who either visited the elephant house or the primate house but did not visit both. So how would we figure those out? Well, the easiest way I can think of would be to take 271 minus 185. So that's going to give us this right here, right? And then over here, actually, let's go ahead and do that math really quick. What is that? 271 minus 185 is 86. Sounds legit. Should be about right. And then let's figure out this one. Wow, that was a terrible arrow. So it's 246 minus 185. And what is that? 246 minus 185. That's 61. So now we know this bit, this green bit right here, I'm going to make it yellow. This bit, we know this bit, that is 86, and we know that's right here, right? And we know, we'll go orange, we know this bit, and that's right over here, that is, what was it, 61. So if we wanted to know the total people who just went to the elephant house or the primate house, what we could do is we could add those two numbers together. So that would be 86 plus, what is that, 61. I just can't remember. 61, and when you add that together, you should get 147, and that is our answer. So not so bad, a little bit intimidating. Let's go back and see what we did here. So we read the problem. We put the information we knew in an appropriate data structure. So in this case, we put the information in a Venn diagram. When I start hearing about, so many people went to both or went to all three, that tells me Venn diagram. Once we drew our pretty picture, we figured out what exactly we needed to know. That were the green areas that we did right here. I'm just drawing all over my stuff. I love colors. And right there. And then we figured out what both of those were, and then we added them together right down here to get our answer. So that is very typical of something you're going to see on your first midterm. Let's go ahead and go to the next problem, which is also really, really typical, both in the kind of problem it is and how they ask it, because otherwise it'd be kind of bad. So let's check that out. So the next problem I chose to look at was number 17. Again, this is the review exercises for chapter 1. I like this one because it is one of the balls in a box book questions, and I don't know why, but teachers really love these balls in a box questions. So you are going to see at least one, if not several, in the midterm, so you really should get kind of comfortable with them. And this is a nice one because not only does it have you draw out the tree, which is really common on these midterms, or at least identify the correct tree, but it also has you fill out the whole answer space. So let's go ahead and read the problem first, and then we will go ahead and start talking about it. So a box contains 3 red, 1 white, and 2 green balls. An experiment consists of drawing balls in succession without replacement and noting the color of each ball selected until either a red or 2 green balls are drawn. Draw a tree diagram for this experiment and list the elements in the sample space. So the first thing we're going to do is we're going to write everything down, and again, I kind of like to draw what I'm thinking about. So I've got a box there. We've got 3 red, 1 white, and what is that, 2 greens. And so a thing to note here is the colors, the balls don't have numbers on them. So if you draw, the first green or you draw the second green, they're not 2 separate balls. That may not make sense yet. Hopefully when I start drawing the tree, it'll make a little bit more sense, and I'll try to clarify. That's where people tend to run into problems with these kinds of questions. So what's the next bit of information? Well, we're going to stop when we get either 1 red ball or 2 green balls. And this is what makes the problem nice, because otherwise this would be a really, really big tree, but this way it's not so bad. So let's start by drawing our tree. So we have our box, and from that we could pull a red ball, and from that we could also pull a white ball, so that's our other option, or we could pull a green ball. And so looking at this, and I want to make sure it's visible, and I'm going to do it in blue because that's one that we don't have anything else happening. Once we hit a red ball, we stop. So that's the end of a tree node or a leaf. So we're not going to keep going on that. But we could draw some more out of the white and the green. So let's go ahead and keep going. So from the white, we could draw a red, or we could draw a green. Can't draw another white. There's only 1 white ball in the box. So again, this ends it, right? We drew a red. So now we've got white, green. And what are our other options there? Well, let's just keep going down this branch. There's several ways you could do it. Actually, we're going to do the other way. I'm just flip-flopping all over the place. So we're going to keep on the same level, and we're going to go over here. And if we drew a green ball first, we could draw a red, or we could draw a white, or we could draw a green. And the reason I went over here is, again, we can start pruning this tree pretty hardcore. This red, well, once we draw a red, we're done. Once we draw 2 greens, so I drew 1 green, 2 greens, right? So that one's done. And now we just have 2 branches we need to worry about. So let's keep growing our tree and see what happens. So if we drew a white and then a green, we could draw a red, or we could draw a green. And I didn't mean to do that. I didn't want to circle my red yet. Or we could draw a green. And let's go ahead and see if we can trim any of this. So if we draw a red, we're done. If we draw 2 greens, so we've got, we drew a white, we drew a green, then we drew another green. That's 2 greens in a row, so that means we're done here. And now we're going to go back to our final branch that we're working on, where we drew a green and then a white. And what could we draw? We could draw a red, or we could draw a green. And again, this is pretty nice. We could trim out this red, or we've got, we drew 1 green, 1 white, another green, so that's 2 greens. So then we're done. So this is what our tree looks like. We could go here and draw a red. Oops, I'm going to go to a different color so you can see. We could draw a red. We could go down this branch by starting with a white, or you could go down this branch by starting with a green. My suggestion is, when you reach the end of a branch, circle the leaf. So that's these terminating or end nodes. Use big words there. That's the bit at the end. You can't go any further. So circle those. Don't cross anything out. You want to be able to read them because that's the next part of this problem. But do circle them so it's really obvious when you're coming back to look at it what's the end. And then my other recommendation is try to keep everything organized. So if you'll notice, I put my reds here on the left. I tried to keep my whites on the bottom or in the center, so I kept it in the center here. And then I tried to keep my greens to the right. And that's a personal preference. You'll also notice that I tend to draw my trees down, whereas I'm pretty sure most instructors that I use like to draw them off to the side. I find this much, much, much easier to keep track of, so totally up to you, but these are my recommendations. So that's the first part of this problem. Let's look at the second. So what else does it want? Well, it wants us to write down... I gotta find my spot. List the elements in the sample space. So pretty much they want us to list the ways you could get to the answer. So we're gonna make a nice big happy set of these. They don't say you have to do it that way. So the first one would be just R, right? And so that's I'm gonna try to, that's just that one. And then the next one would be white, red. Right? And I'm not going to go through all of these, but just for the first couple, white and then red. Okay? Then the next one, let's see, is going to be white, green, red. And as you see, I mean, this isn't terrible, but it does get a little nasty. So that's white, green, red. And then what else do we have? We have white, green, green. Okay. And that is, let's try to go a slightly brighter color, white, green, green. So that's that branch. And now we've just got this final branch to do. And I'm actually going to wrap it down because it's a little big and I'm kind of messy here. It's kind of hard to see everything at once. And so that would be green, red. And that is green, red. And again, you'll notice I'm kind of going in a pattern. This is to prevent me from missing anything. So green, white, red. That's green, white, red. And let's see, green, white, green. And that would be green, white, green. And then finally, green, green. And typically on these midterms, I've noticed that they give you these in multiple choice. So on this one, you know, it might be in different order. The order doesn't matter. The point that's important is that you have all of these little bits in here. So that'd be green, green. And so I'm going to zoom out and kind of talk about both of these problems really quick. These are both really typical stuff that you'd see on a midterm for any finite class. So the first one we did a basic Venn diagram. We started by writing down everything we know, putting it in an appropriate data structure, so we put it in the Venn diagram. We figured out what we needed to know, which would be this bit and this bit, and those are the things that people only go to one, so either the elephant house or the primate house, and then we added them together, and that gave us our answer. Down here, we kind of did the same thing. So we wrote down, I'm going to go to a nice kind of cyan. We wrote down what we know. We wrote down further what the stopping conditions were, and so there's tons of ways to call these things. I like to think of them a big red stop sign. When you see that stuff, that's when you stop. You don't need to keep drawing the tree. Then we drew the tree, and then we traced our tree and we wrote down all the answers, and that is the answer for number 17. So these are both relatively straightforward problems. I don't think they're going to give you any problems. If they do, go back and review the sections of Chapter 1. You do want to be comfortable with both Venn diagrams and tree diagrams. Really, really important. So I think you won't have any problems. Check them out, and I think you'll find them relatively straightforward.